This is tutorial 6A question 3C and 3D. They are related. In this question, we are interested in given x omega, we want to find x of n. So let's recap. X of omega is the Fourier transform of small x of n, and it is given by this equation. And to get x of n back, we have to perform inverse Fourier transform, and this is the equation that we are going to apply. Now, we're going to use this property, the shifting property. So let's assume that this guy is a function, some function of t, and now we have a delta function. Now, the shifting property of the delta function is this: when we multiply a delta with the function and this delta, remember what this means is that at this time t naught, there is a delta here. This is delta of t minus t naught, and now this is t. And now assume that we have a function here, and this is the function phi of t. When we multiply this together and we integrate, then out comes a value at t naught, and this value is exactly this value here. So this is a shifting property of the integration with a delta function. This is what this notation means, phi t naught. So this is a continuous function of t, and now here we are only extracting this value at this particular instance times t naught. Now with these three equations, we are going to now examine what does when we are given x of omega like this, 2 pi delta omega minus omega naught, what is the equivalent, or what is the xn that has produced this x omega? And of course, we then apply this equation, the inverse DTFT equation here, which is 1 over 2 pi integrate across a period of 2 pi, and this is x omega, so it's 2 pi over delta omega minus omega naught, and then we have e plus j omega n. Now, so we see the delta function multiplying by the complex exponential function. The 2 pi, of course, disappears because it cancels. So this guy simply becomes this guy. So only at omega equals to omega naught is there a non-zero value. So it's ej omega naught n. So what it means is that a complex exponential rotating at omega naught, its Fourier transform is a delta function at omega naught multiplied by 2 pi. Okay, so this is the DTFT of ej omega naught n. Now, in the second question, Q3D, we're given a constant. So a constant can be thought of as ej0n, where omega is equals to 0. So therefore we substitute omega equals to 0 here, and therefore now we basically have a 2 pi multiplied by the delta function. So we have a delta function at omega equals to 0. So this is the Fourier transform pair. This is the, what do you call that? It's not the unit step, it's the unit, it's the 1. Okay, so this xn equals to 1 forever. Okay, and this Fourier transform is a delta function at omega equals to 0 multiplied by 2 pi. Thank you.